usually quite a good indicator.
Hello.
Hello, everybody. It's got all very fancy now with like microphones and everything. It's Alex's streaming stuff. Hello to the stream. Thanks for coming to IoT Liverpool. It's good to see a load of people out on kind of a pretty grotty evening, I think, wasn't it? It was the last time I went out. I've been here all day, so I've not noticed. Thanks for coming. If it's your first visit to Does Liverpool, welcome to Does Liverpool. If you want to have a look round at all after the talk, give me a shout, or Jackie would also, I'm sure. Okay, Jackie won't be around, so yeah, give me a shout and I can show you around the rest of the space. This is the events room, but we're a co-working and maker space, so there are desks the other side of that wall, more desks through there, and then also 3D printers and laser cutters and CNC machines and all sorts of toys over that way, and you can come in and book space by the half day or the day or the month, and kind of work from here, or just mess around with stuff from here. So give me a shout about that if you want to know more. So this evening we have Nic is going to be telling us all about radio modules. It's LoRaWAN. Yeah, I knew it was low power radio, but I was like, which kind of is it? So he's going to be telling us LoRaWAN. So without further ado, I shall hand over to you, Nic.
Thank you very much. Cheers, Aidan. So I'm Nic Burkinshaw. For 40 years, I've been in IT. My first job was as a wireman in a small electronics company. And the first engagement with computers I had was with an Intel 8-bit micro. But before that, I was designing paper tape reader punchers based on pure TTL logic and this magic chip called a UART. And we managed to get serial data in and out and punch tape and read tape. It was fantastic. And then I got into writing code for the IBM PC when that came out in 1981. And I amazed a guy from Cadbury's by rotating video of a Cadbury's cream egg. And that was by swapping pages to the colour card. And he couldn't believe it because he'd never seen anything like it before. So then I moved on to various things, and unfortunately I ended up in support for a long time and became a colour engineer for a Dutch company called OSE, and then got into something that I really enjoyed, and that was thin clients. So thin clients, embedded Linux, and client-server technology, and then moved into mobile device management and security. And throughout those 40 years, I'm an inveterate geek, and so anything comes into the house, I have to take the back off to find out what it does. And LoRaWAN was kind of like that 2 years ago for me. I got really excited about the idea of something that was so low power that could manage such long distances. So I just put this presentation together based on something that I've written an article for the Linux Journal. I've got my own blog page at nicbkw.com, and I did a presentation at the Things Network conference last October over in Norwich. So it's a sort of a conglomeration of some of those things. Yes, it's a PowerPoint slide, and there are probably 30 slides, but I will keep breaking in and out to show you some live stuff as well, so it's not death by PowerPoint. So the idea here is that I'm going to talk a bit about the underlying technology for LoRa, why it is so useful, why it's so effective, and then concomitant with that is this whole idea of link budget, because we've got very low power, so we have to be very careful how we use that power and make the most of that power by having the right kind of environment to get the signal from the gateway to the node and back again. That's all to do with antennas. And then on top of LoRa is the network protocol, and that's LoRaWAN. So LoRa is not LoRaWAN. LoRaWAN is not LoRa. It's two different things. But LoRaWAN depends on LoRa for the operation. And then I'm going to say a little bit about the Things Network, which is an open source solution for getting your data from your nodes through a gateway into the cloud. I'm going to show you a little bit of live data, and after the presentation, I've got a little show and tell desk over here with some live nodes, and I'll show you the gateway that I built 2 years ago to get all this stuff started. And then at the end, we're going to talk about how you actually get the data from the Things Network into something that you want to use. So there are some key technologies with LoRa, and the first one is spread spectrum. And unbelievably, the original patent from this came from a Hollywood superstar called Hedy Lamarr, who just happened to be a mathematician in her spare time. And this guy who was an avant-garde composer who created piano rolls for automatic pianos. And they brought the ideas together and said, well, what if we did frequency hopping by actually synchronizing transmitter and receiver with piano rolls? So spread spectrum is important because you'll see that when we're talking to the Things Network, we've got a possibility of 8 channels, and we can randomly select the next channel to talk on. The other bit about this is chirp spread spectrum. So chirp spread spectrum is a really effective way of using the available bandwidth. And it's so effective that dolphins and bats did it long before humans did. So the whole thing about chirp is it's a characteristic signal of rising frequency over time, and bats use it. And that characteristic signal that we're using with LoRa is very easy to distinguish from atmospheric noise and from other noise events within your area. So even if there are decked phones and there's Bluetooth and there's Wi-Fi and there are industrial motors, they're all causing EMI and RF interference. The characteristic chirp signal, the signature of that chirp signal, is possible. The chip technology analyzes that and recognizes that frequency increase over time, and is able to lock onto that with a preamble and then capture the data. And the other thing about LoRa is that it's flexible. So the third part to this is spreading factor. So spreading factor is basically how long do I take for that chirp. If I want to get more data through, then I need to keep that chirp length short. But if I've got a problem with noise or distance, if I make that chirp longer, then it's possible to travel over greater distances. Just think about what happens in a crowded room. You tend to talk more slowly to the person you're trying to get in conversation with. So you could try shouting, but then we don't have more power with LoRa. We have a fixed power budget. So what you say is, okay, well, talk slower. Okay? And the result of all this technology, the spread spectrum, the chirp, and the spreading factor, gives us a solution which is very, very effective. So with that very low output power, last September, they launched a balloon in Holland somewhere, I think, and they managed to connect between that balloon and a ground station, a distance of 702 kilometres. So 702 kilometres in free air, when you've got a signal which is 20 milliwatts, is pretty astounding. And there's a project going on at the moment called Lacuna, and they're going to be doing LoRa from space. So we're talking all of a sudden, I'm not sure how many kilometres, but thousands of kilometres from space to a ground station. And compare that with what other things you might have around you. So your key fob for your car. Okay, it's only 2 milliwatts, but that, how close do you have to be to your car to make the key operate? I know there's that kind of trick where you stick it on your head and you can do it across the car park. But, the other thing is compare it to your cell phone. So your mobile phone, 1 watt will get you to a dedicated mast with a specially designed antenna, and it'll get you about 30 kilometres line of sight. And that's 1 watt instead of 20 milliwatts. So the LoRa technology really is very, very interesting. The other part to LoRa is that it operates in license-free bands. So it's a big benefit in that you don't have to start paying license fees. It's not like narrowband IoT, cellular phone, where you're going to have to pay a CSP, a telco, for SIM time. This is free to use. There are some trade-offs, and I'll talk about those, but it's a solution which will allow you to get small amounts of data over reasonable to long distances at very low power, where the sensor device, has got a battery that can last 5 years. And these license-free bands, if it was a perfect world, would be able to use the same device worldwide. The reality is there are different license-free bands in India, Asia, the US and Canada, and Europe. Now, there's a new directive which came into effect in October, where in the EU we're going to be allowed to use the 915 megahertz band as well as the 868 megahertz band. So it will give us more options in Europe. But right now, if you want to build a product for global use, you're going to have to take that into account. There are a number of manufacturers who are offering LoRa radios that will work both here in Europe and in the US. But you do need to have very cleverly designed RF circuitry to support that. So just to summarise what we've got in terms of LoRa, please don't expect to transmit video and audio over LoRa. We're talking of very small packet sizes. So when I've quoted here 230 bytes at spreading factor 7, so that's a very short chirp, so we can get a lot of data through. That spreading factor, even so, only allows us 230 bytes maximum. And when we add the overhead of a network protocol with LoRaWAN, then that's reduced down. So expect to send a maximum of tens of bytes. And if you want to use the maximum distance, expect to send less than 20 bytes. And it's perfectly possible. You don't have to send the full GPS location every time. You don't have to send the full value of a temperature reading every time. You can accumulate data, you can send deltas, you can do all sorts of things in terms of data compression. But this LoRa technology is really just for that. It's for sensor technology, for things like heading height, temperature, location, and so on. What's really important about LoRa, and I've mentioned it a couple of times already, is the link budget. So with link budget, what we're talking about is this triangle. My wife's a photographer, and she does a triangle like this for shutter speed, aperture, and ISO. You have to trade off 2 against 3. So with Bluetooth and Wi-Fi, you can say high data rate, lowish power, but very short distance. What we're looking for here is low data rate, low power, but big distance, and that's the trade-off. And so when you look at it, it really is mostly about the antenna. So the problem with a lot of implementations of LoRaWAN and LoRa technology is that people assume they can buy an antenna in from China, and because it says it's an 868 megahertz antenna, they think, well, that's what it'll do. It'll be optimized. It'll resonate at 868. Very often they don't. And then when you look at an antenna, you have to make sure that it's configured in the right way with the correct ground plane, for example. The little diagram at the bottom of this page is talking about an optimum graph from a dipole. So the idea here is that the signal, if you've got your antenna vertical, the signal will be optimized in the horizontal plane. And that optimization is termed gain. And don't be confused when people say, oh, my antenna's got 12 dB gain. It hasn't got 12 dB gain. It's a passive, it's a bit of metal. It doesn't have any gain. What it does have is focus. And what it will do is it will focus the signal in the particular area, which is why when you go past the dipole, you might want to consider something like your TV aerial of old, not your satellite dish, but your TV aerial, which is something called a Yagi array, which has a reflector, an active element, and then directors in front of it. And the whole idea of that is that the signal is pulled in that way. And you can also transmit with a Yagi in that way. But that's a very focused signal. And you can determine the direction and also the polarity, whether it's vertical or horizontal. But with a dipole, like all of the examples here, you basically need to make it mounted so that you're transmitting horizontally. The other thing about link budget is that it's much better if you're higher up and you've got clear line of sight because the signal is absorbed. So in an urban environment, your signal may be greatly reduced because of it being absorbed by buildings. And we're dealing with signals here at sub-gigahertz signals, but it's 868 megahertz. There are other formula to do with RF penetration, but take it from me, that Bluetooth and Wi-Fi at 2.4 gigahertz has very low penetration. Your doorbell at 433 megahertz has pretty high penetration, and 868 is somewhere in between. So you need to take all of this into account. And when we're looking at the typical antenna, I've got two examples here. The one on the right is a quarter wave vertically as the active part of the antenna. And then it has radials, sometimes called counterpoise elements, at 45 degrees from the vertical and 90 degrees separation. And that design gives you an effective ground plane for the vertical element. And that gives you a good approximation to a solid ground plane. The one on the left here is an evaluation antenna from TI, and the actual active element of this is this bit. So it comes down through here. The rest of this piece here is the recommended size of ground plane for 868 megahertz. So when you're considering that you want to make your board as small as possible, if you're going to use your board as the effective ground plane for your antenna, you need to be aware of this. Actual design of antennas is the most crucial part, I would argue, for a successful LoRaWAN solution. So just to sum this up, link budget is all about where you stick your gateway, stick it up high, stick it on the side of the building, the antenna in free space if possible. The connection between the antenna and the node or the gateway should be as short as possible, with as few connections as possible, because every connection introduces a loss. The cable introduces a loss. And you're only starting out with a very small signal to start with. You really need to make best use of what you've got. And then also, to make things easy for yourself, try and avoid sticking it in on the same mast or in the same area as your GPRS, GSM antenna, microwave antenna, other things like that. Don't stick it next to the air conditioning fan, that kind of stuff. So this final picture here is just to give you an idea about some of the gateway sizes. So see here, that's a fairly good implementation where there's free space around the antenna. It's got a ground plane. I suspect actually this is what might be called a collinear antenna, a multi-element antenna. And also another solution here. This is proven to be probably the most popular external gateway at the moment from a Swiss company called Lorix. It's a very good price. It's built into a nice IP-rated solution with a waterproof end connector for the antenna at that end. If you just bear with me, I'm going to show you if I can get to it, show you an example of something I do for testing. So you can see this. I don't know if you see the URL there, https://nicbkw.com. This is all on my blog, so after the show, please take a look. This is a solution that's laid out on the desk over there, but basically what we've got is a USB SDR, software-defined radio, something called an RF bridge, and this is a white noise source. And the idea is that, and there's a terminator there. So the idea is that the white noise source provides an RF frequency across the whole band. And if you scan with the SDR USB using a piece of software called RTL Power, it will show you a frequency, a signal strength across the band. And if you do it with just the terminator in place, you should have a fairly flat signal. And we use that as a baseline. And then you can quickly swap over the antenna, and you see I've got 6 lined up there for the next shot. 6 lined up there, and you put those on in turn, and you can see, you can plot the signal strength for each of those aerials. And the important thing is that when the antenna resonates at the correct frequency, the signal received by the SDR radio will go down because the antenna is being effective in the RF bridge. Hopefully. Oops. This is an example plot, and it looks a bit of a mess, but what we're really showing here is that the brown trace, which goes along here, dips at just about where we want it to, at 868 megahertz, and doesn't dip significantly at other frequencies. So we could say that that brown antenna, antenna 1, is good for our purposes. It works well for LoRa. Whereas the pink trace, this one, you can see it doesn't resonate anywhere near 800 megahertz and goes off. I suspect it was probably a 2.4 gigahertz antenna, but I didn't trace up there. So it's quite a useful way of evaluating antenna. It's not the whole solution. The problem with antenna is that you can say, okay, well, I'll use the brown one, but then I'll put it on a box, and the material that the box is made from will affect the capacitance, and it will detune the antenna. Or there might be a large LiPo battery, or even a metal case or something else, which will affect the operation of the antenna. So the only way that you can really optimize the solution is by doing field tests, by actually going out into a field, clear space, with a node and a signal strength meter, and actually checking for the signals. There's a lot of conversation about this on the Things Network forum. Some very interesting articles. Right. You all seem very attentive. I'm very impressed. Just trying to work out how I do this. Okay. So what comes next? The LoRaWAN protocol itself. So this runs on top of LoRa, and it's a protocol. So it's a network protocol. So it has headers and checksums and a state machine built in, and it does everything you need it to do to ensure that your data from your node gets securely into the cloud. It's a technology which is effectively laid out as a star of stars. Your nodes need to be able to see a gateway. If they can see more than one gateway, that's good, because the way that the LoRaWAN protocol works, that data will be deduplicated. So you could have a mesh, well, not a mesh, but you could have a number of gateways receiving the data from one node. But the network protocol will resolve that and only allow the gateway with the strongest received signal strength to talk to that node. So one of the things you should understand about LoRaWAN is that it can operate in a number of ways. The way that almost all nodes work is something called Class A, which means that everything's quiet, and then the node needs to send some data. So it will wake up and just throw out some data. And hopefully, the gateway that it's registered to will pick that up. If you're war driving like Adrian was riding around on his bike with the stuff in his saddlebag, then he's hoping to pick up various gateways as he's moving around. And round Liverpool, you get a pretty good response, don't you?
Yeah, a few. South Liverpool wasn't quite so good.
Yeah, good. Yeah. So the idea is that the node transmits when it needs to transmit, and you can only send back to the node immediately after you've picked up a message from it. So Class A basically says, I don't care if you've got something really important to say to me, you can't say it to me till I've spoken to you. And you've got two chances. So basically, I'll hold my receiver open immediately after I've transmitted for a certain amount of time, and then I'll shut it off, and then I'll open it up again a couple of seconds later. If you don't get to me that time, you're going to have to wait until I transmit again to send me a message. So understand the restriction of what you're doing with it. The way that the protocol works is secure. It's encrypted. It uses 128-bit encryption, and it uses standard AES encryption technology. There are two levels of encryption. One is with something called a join server, where there is an exchange of keys and then there is a key generator from that, which is then used through the network server to talk to an application server. What this ensures is that there is a secure link between the node and the application. And so from this diagram on the right here, you can see that the nice coloured bits on the left-hand side, you could have a LoRa node in a dustbin or fire detection or vending machine or whatever. That information is picked up by gateways, and that data is then pushed through the network server to what we call application servers. And I'm going to show you some live data in a minute. There are some restrictions. Because it's a license-free bandwidth that you're playing in, you can't hog the bandwidth all the time. So you can't continually send messages. Adrian and Alex won't like it because I'm actually continually sending messages from a load of nodes over here, but I'll show you what's going on. It's purely for tonight. I promise I won't do it normally. So there are a number of things. Your power output is limited to 14 dB. So even if you go onto a Chinese website and they say 868 power amplifier, 100 milliwatts, you can't use it. It's not legal. Don't do it. And the other thing is that there's to ensure that you can get the maximum number of nodes active on any network within your area, you have to be able to support at least 3 discrete frequencies within the band, so that you can randomly select one of those 3 frequencies for your first connection to the gateway. And then from that, you can then opt to use one of 5 remaining channels to talk back. And so that's the spread spectrum part of the technology. And you may see advertised single channel gateways, and they are a lot cheaper. They're the same price as a node, but they're not LoRaWAN. They don't adhere to the protocol. They're not accepted by the LoRa Alliance. And for this particular reason, they don't support multiple frequencies. They only support 1 frequency. You can use them for testing purposes, but you cannot use them for production. Here's the crunch. So because this is a license-free network, you are limited duty cycle. And that limitation is 1%. So for 99% you've got of your time, you've got to stay quiet. Now, for a battery-powered sensor, that's excellent, because that's what you want to do. If your battery needs to last for 5 years, you need to stay quiet most of the time. And that Class A operation where you only turn your receiver on once you've transmitted also helps to reduce that battery drain. So what we're talking about here is a solution that, at that spreading factor of 12, remember that's when the chirp is spread over a longer period of time. So that's good for long distance but low data rates. You can only get 20 messages of 10 bytes out of a 24-hour period. That's your duty cycle. If you're able to connect at spreading factor of 7, then that's great. I should also mention that there's something called adaptive data rate. So the connection between the node and the gateway can be flexible. And so you can start out at a low data rate, and if the gateway determines that the received signal strength is such, it can say, okay, I'm quite happy, I can hear you. You can reduce your spreading factor and thereby increasing your data rate. So there's some very clever things that go on with that within that LoRaWAN protocol. So this whole solution that I've talked about, I hope you understand the LoRaWAN technology, the LoRa technology, the LoRaWAN technology, and at least understand it from the node point of view. There's an awful lot that goes on in the network. And the Things Network is an open source solution, so it doesn't cost you any money. But they have a global solution. Right now, they've got nearly 60,000, I have to get the numbers correct, 58,000 members, something like 7,000 gateways worldwide, and it's growing. And they've only been operating for 3 years, and I think it's going to be a fantastic Things conference at the end of this month in Amsterdam. So just to understand what the Things Network provides for you, it basically does all of that within the dotted box, apart from, well, it does everything in there. So these are your nodes are out here, your gateways. You've then got, sorry, this is your gateway, I beg your pardon. And then everything else here is provided by the Things Network. So you've got that joint server I talked about, the network server, the application server, and so on. And then there's integrations to allow you to get that data out of there. I'm just going to swap over to a live picture. Are you all very bored yet? No? Okay. Let's see where I am on this. To find it. So this is my live network, and I've actually got a number of gateways. Currently, the only gateway that's live is the one that I left at home, which is the a commercial product from an Italian company called Mbit. This one is here and not plugged in. So I'll show you that. But I've got an application called Remon, and on that I've got a number of devices registered. Some of those devices are live right now. So if I go look at the data for Remon, you can see I've got a number of things that are going live. So Heltec is the yeah, you should. Yeah. So Heltec is this one. And the rack is that one, rack wireless one. The PyCon one is this one. And we should get, we've got the Sparkline one, which is the one on the desk. And then there's another one called Sodak, and I'll talk about Sodak. I'll just show you if I can. I'll show you the. So this little board here. It's got something called a system in package from a Taiwanese company called Sparkline. And so inside that package is the Semtech chip and an STM micro. And that's now a common kind of design where both are combined as one unit. And there are a number of manufacturers. So there's a company called USI, there's Murata, Sparkline, Rack Wireless, and a number of others who do this kind of thing. So lost my mouse. So what you can see coming up here is data and payload, and that payload is encrypted, and it might contain, I can't remember on these nodes, but it might contain things like temperature, time of, humidity, pressure, location, those kind of things. And you can see the data, see the devices, see your gateways all through this console. So one thing you can see on the right-hand side here is the integrations. So it's great that, you know, the Things Network provide all this infrastructure for you. You don't have to use the Things Network. There are a number of other commercial solutions out there. There's one called Laureate. There's actually another one called LoraServer.io. And you can even, there's a guy sponsored by Xerox on GitHub who has written an open source version of that complete network, LoraServer network. So you can even install it on your own servers if you want to. But the benefit of having the Things Network in your equation is that it's open source, they've got a service level, and they've got a global solution, and they've got resilience. So why not use them? They've got these integrations, and I'm going to talk a little bit about using MQTT. So the integrations, you can do things with Cayenne, Amazon Web Services, Azure from Microsoft, all sorts of people. And TTN very nicely provide lots of SDKs and libraries and examples to integrate with whatever you want to do. If you look at the Things Network, it has a section called Labs, and there are 3 or 4 articles that I've written on there. One of them is talking about integrating with Node-RED, because I know Node-RED is a favorite. But what I'm going to show you here is a very simple solution. Well, I think it's simple. Based on MQTT, Node.js, and MongoDB. So to get an MQTT interface, I'm using the open source package Mosquito. To get Node.js, well, I'm using Node.js. And I need somewhere to store the data. Now, the data that you get from MQTT and from TTN is effectively something called JSON format. It's an adaptation or an evolution of something called XML format. It's basically, it's a text-readable solution for passing variables and values. And I use a NoSQL database simply because NoSQL databases deal in JSON formatted data. So there's no requirement to convert from a SQL record into JSON and back again. And it's very simple to set this up. You can set it up on a Raspberry Pi. And if you're at all interested, this is explained in full on my blog site, that nicbkw.com. So the thing that I said at the start was, you know, talk about the protocol, talk about the RF technology, talk about the protocol, show you the antenna and link budget and the rest of it. And of course, the bit that's really interesting is how do I get to apply all this data that I'm acquiring from my nodes? So you should understand that the Things Network is not a data store. It simply enables the data to get from your node into the cloud. You've got to be able to take it. Now, they make it reasonably easy for you by offering it through an MQTT broker. So all you have to do is to subscribe to your particular channels on that MQTT broker and pull that data from there and into your database. And so this is something that I showed in Norwich it was weird because a lot of people sort of been a bit interested in talk about somebody's product, a bit of marketing, the rest. I started showing a bit of code and people started writing things down. You don't need to write it down, it's all on the web. But anyway, so a typical Node.js program application, you need a definition of the package that you're building. You need, in my case, a configuration where you store passwords and paths and names. The actual application itself, and because we want to keep things secure, we've taken the public certificate off TTN, and we use that to allow us to use MQTT-S as a secure connection. So the package for Node.js is very simple. It just gives you a name, a description, and tells you what the package actually, what the application depends on. In this case, it's MongoDB, an MQTT, and the Things Network. These are all NPM packages, Node.js packages that you can download and install. This is the eyesight test. But all I really want to explain here is that it's just a separate file where you store your configuration. So in there, I've got things like the actual strings that I'm going to send to the broker when I subscribe to it, including my unique key, the public key for the MQTT-S, and also how I connect to my database. I have a host up in the cloud. It's called db1.remon.io. It's actually a server, a real bare metal server somewhere in Paris with a company called Scaleway. And if you're looking for real physical servers, I'd certainly strongly recommend you look at Scaleway. I don't get paid by them, but it's just it's been really, really useful for me. So you're not talking about virtual images, you're not talking about EC2, you're talking about a real live bare metal server that you can get for €3 a month. I think it's pretty fantastic. The actual application is in 2 pages on these PowerPoint slides, so it's not big. And this basically pulls the data from the MQTT broker into my database. That's all it's doing. So it basically makes the connection and puts it into the database. And you can access that data in a number of ways. Hopefully I can show you a couple. I need to get this over to here. So this is a thing called, I can't remember, NoSQL Booster, I think. It's a free package. NoSQL Booster. And you can see what I've done is I've logged into my server. I've logged into my database. And I've got a query. And this query is going to pull data, in this case, from that PyCom box over there. So while we've been talking, that node has been talking through the gateway here up into the cloud, and that data has been published by the TTN MQTT broker, and an equivalent version of the code I've just shown you has been running on my server in Paris, pulling that data into the database. And so if I run this, it's live, it's got the data from there, and I can't remember exactly what it shows. So it's pulling data up onto here. That's old data. But anyway, so that's one way of talking to the of talking to it. Another way of talking to it is, and I think this is still up. This is going to SODAC. Now, SODAC is sitting back at home in Cheshire, in a place called Wincham, which is between Northwich and Knutsford. So it's fairly landlocked, but it's pretending it's a boat. Apart from the license expired on my Google Maps API, it's giving me some information. So this is live data again from that database in Paris that's been updated. And you can see there's some readings here. And if, and just prove it is live, if I go and say instead of just 10, I want to look at the last 100, it will go through. So this code again is just another piece of Node.js being activated by a call to a web server. And you can see from the URI at the top there that I'm basically saying, identifying the data, identifying the device and saying how many samples do I want to look at. There are some other things that I've done in the API so I could actually spit out more data from that. But that's the idea. Just about finished. So I think just finally, just to wrap everything up, and I'll be around to do some show and tell on that desk over there if you're interested. The Things Network is an excellent way to get your data into the cloud. And MQTT, we've had lots of people using it. I know Adrian used it, all sorts of people use it. Here it does. And it makes for a great solution. I'd recommend, if you've not already looked at it, look at MongoDB. It's very simple to use. Node.js, I think, really is a no-brainer in terms of building up simple applications to work with JSON data. And that NoSQL Booster also is a no-brainer in terms of it's free to use. There are some restrictions, but it's free to use. So please, thank you for your attention. And if you want to take a look at any of this, take a look at the Things Network and also take a look at my blog. Thanks very much.
Thank you very much for that, Nick. I guess, have you got any time for one or two questions?
Absolutely, yeah.
Any questions at all? Ed at the back first, you can wait. Alex, sure, your staff.
You mentioned antenna gain or focusing each other. How does that impact on the limits on the power output? Is it the focus output?
You're absolutely right. That 14 dB limitation is the ERP at the antenna. So you can have an antenna with effective gain of 12 dB as long as you're losing some in your cable between the node and the antenna, or the gateway of the antenna. It's that limitation is on the effective radiated power from the antenna.
So that
you can't cheat, in other words.
Boost it back up to get it to what it was when it came, what you've lost in the system.
Yeah. That's why you'll see these external gateways, because then there's a very short path to the antenna. The alternative is to use extremely low loss, extremely expensive coax. Yeah. I've got a 5 metre length of coax, which is over £100, and it just happens to have a 0.1 dB loss per metre. So that's why it's expensive. But you'd rather really stick the box up in the air with the antenna.
How do they police that, just out of interest?
They don't at the moment. It's a bit like you're on your honour.
Yeah, you seem to next, Alex, you're all right.
Thank you.
slowly, in my slow way, starting to understand what you mean about using NoSQL databases and MongoDB, and it sounds awesome, and I will have to have a look at that, so thank you very much.
Okay.
One thing that came to mind in listening to you, I'm not sure if I missed it, but it was very interesting to learn a little bit about the asymmetry of transmitting from nodes and to nodes, and that's quite different, isn't it? Could you expand on that a little bit?
Yeah, so it's all to do with power consumption. And so if you have the receiver powered on all the time, that's termed a Class C device. But if you've got the receiver turned on all the time, then you need to have some external power to it. So you can't make it a battery-powered sensor. I think there are certain situations where you might want to operate in Class C, where the receiver is available all the time. But the majority, I would say, more than 80% of nodes out there are working in Class A. So Class A is transmit and then open to receive windows for a short period of time after you finish transmission.
One of the things that I came across, and I think it was one of the things network, and I might be wrong, was that, you know, talking about bandwidth constraints, you can send, you know, X number of messages per day within your 1% duty cycle, but seemingly the constraints on sending downstream messages from your server to the node even more constrained. You're down to just a few messages a day. Is that right?
So you're talking about occupancy of the airwaves from a particular point, and obviously the node talking up to the gateway, it's many to one, whereas the gateway will be talking one to many. So if it was sending lots of data to lots of devices, then its duty cycle would be well over that 1%.
Thank you. Last thing, would it be possible to get a copy of your slides?
Absolutely,
Online,
yeah,
okay?
yeah. I'll make them available on the blog, but if you want to post them on a Does place,
I'll link to that.
yeah, yeah, very good. Okay, yeah.
The spreading factors
Yes.
linked to the energy consumption as well. So ideally, you can.
It is. It's a very good point. Yeah. So if you've got 10 bytes that you need to get to the gateway, then if you can send it to SF7, the transmitter is transmitting for a shorter amount of time, therefore using less power.
So always, if you can transmit always in the.
Yes, if you can use SF7 all the time, fantastic.
Yeah.
But the reality is, atmospheric conditions, you know, all of a sudden you transmit it across the Mersey and there's a liner in the way, you know, those kind of things, then you change your spreading factor accordingly. And that's why there's this thing called adaptive data rate, which allows you to change the spreading factor on the fly. Okay?
Just a very quick question. If you've got two sensors,
Yes.
can they mimic each other? Do you know that the data that the things network gets comes from your sensor?
Yeah. So it's a question that gets asked an awful lot because people are really concerned about security of data. And that's where this join server comes into play, because you start off with a unique identifier for the node. That node sends a request to the join server, and if that join server says, oh, you're a new node, then it'll send an accept back with a key pair. And then that key pair is used then to encrypt that connection for that unique device ID at that particular point in the conversation with that one join server. So if you use that same initial key ID for another node, you set it up with the same one, it won't be accepted because there's already one using that key pair. You can delete a node, and there's some internal working within the Things network which drops off that node identity after a period of time, allowing you to use it for another node. One of the issues that they do have is that I've used, and I would recommend you use, over-the-air authentication, which is this talking to a join server. There's quite a lot of commercial LoRaWAN nodes coming out that are pre-configured with keys. So they bypass the join server and talk directly to the network server. And so you've lost that initial security, and it's perfectly possible to duplicate nodes and have the data coming from more than one node. So over-the-air authentication is another buzzword that you'll see on the Things Network. Anything else?
No, seems to be. Thank you very much once again, Nick. And thanks to you all for coming. I think the next, obviously that's where I look at Alex to see what the next meetup should be next month.
Absolutely.
And Gemma May Potter is going to be coming talking about some of her work with sort of tech and textiles and that sort of thing, I should think. It should be quite different but super interesting. So there'll be an announcement from that on the IoT Liverpool meetup group once we get stuff sorted. And we're always looking for new talks and things as well. So if you've got somebody who can give a talk about something IoT related, then drop me or Alex a line. So that would be good.
I added this last night, so I'm not sure whether everybody saw this, but I did make an offer that I would donate a LoRaWAN node. And the way you get to win this LoRaWAN node is by tweeting about this event using the hashtag IoT Liverpool. Okay? So do that. Do that, and you stand a chance of winning this. I did offer an ST Micro one, but unfortunately it broke. So this is a rack wireless one. Really neat. It's basically it's an Arduino Shield, but it'll run standalone, and it's a full LoRaWAN node.
Cool. Thank you very much for that. That'd be awesome. So we've still got a few beers and there's chatting. There's Nick's got his stuff. Are you hanging around for a little bit? Yeah. So if you want to have a look at this kit that he's got, and if you want to have a look around the rest of DUS to find out a bit more about what kit we've got and stuff there, I'll wander through now and come for a look round. But look forward to coming. See you soon.